Mm-hmm. All right. 1, 2, 3, testing. One,
Mm-hmm.
2, 3, testing. Sounds good. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right. 1, 2, 3,
Okay.
testing. One,
Mm-hmm.
two, three,
Sounds good
testing. Sounds good
to
One,
me.
two, three.
Very nice. It's a very nice.
Deindustrialization in Europe. Oh my God. Anyway, so
Today is the most important day in the history of the universe. So today we is going to go.
where are we going? Let's go to Chat GPT and ask it chatgpt.com or something, or AI, or who knows. The chatgpt.ai. Let me log in. Oh my God, they're raping my eyes. Monsieur Slef. I am Monsieur Slef. This is a not a new computer, a new user that I created. I'm going to start phasing into a new paradigm that I'm going to be streaming my entire laptop. Okay, I think we're ready to go. So we're going to ask ChatGPT, please write a Python program simulate a quantum entanglement experiment. Entanglement experiment. Simulate quantum entanglement experiment in Python can be done using the Qiskit library, which allows us to simulate quantum circuits and experiments in a way that reflects actual quantum mechanics principles. Entanglement is a phenomenon where two qubits become correlated, meaning the measurement of one affects the measurement of the other, no matter how far apart they are. Here is a Python program. Install whatever. Run the following program to simulate quantum entanglement experiment. Okay, this is nonsense. This is not what I wanted. Let me look it up. I did it on my iPhone and I got normal code, not nonsense code. So I asked somebody else, another AI, with the word spin. Can I? Okay. Write Python code to simulate entanglement. Spin. Let's try to add the word spin. Spin. The simile is basic. No, no, no. Don't use Qiskit. Stop it. Don't use. I mean, you can use NumPy and random. Use only basic libraries. No Qiskit. That's good. So particle A, particle B, entangle. Spin A, random. No, 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 no. You don't decide if it's up or down. No, that's not. Oh my God. Jesus Christ. Jesus. No, 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 no. You choose an angle. You don't choose up or down. Jesus Christ. Choose an angle. Quantum. Is there another version? Jesus Christ. The first time I did it with my iPhone, it got the right answer. Let me just take the code. Let me copy the whole thing. Let me forward the whole thing to to what? To my Discord. Let me just copy the whole thing. Let me cancel. Let me copy. And oh, okay. I need to to my other phone. This is gonna be a major hassle. Okay, to this phone. Now let's go to this phone. Get the code. Copy the code. Go to my Discord. No. Mm-hmm. And paste it. Oh, it's too big. Oh my God, it's too big. What should I do? That's where they get you with this nonsense. They don't want you to send big text files. Videos is fine. Everything's fine. Text files? No, no, no. You cannot use text files. No, it's not possible. Not possible. You gotta pay us mucho dinero. Mm, mhm, mhm. So, how would I transfer it? How can? Oh, I can email it. Okay, let's email it. So I'm going to go to my Gmail. I'm going to compose a new email and I'm just going to paste. And that's it. It should already be available for me to pick it up in the Gmail. Where's my Gmail? Let's go to my other account. Let's go to drafts. Here's. Oh my God, it doesn't look too good. Let's see. Copy. To where? We need to open a new what do you call it? Okay, we need a new Google Collab. So collab. Where's the Google Collab? Google Collab. Where do we sign in? Wait, why is this browser settings? Appearance, same as Windows. Okay. But why is this site so, oh my God. How do you add extensions? Find extensions, dark, add, dark. Okay, where's the Google collab? Google, where's the Google collab? New notebook. Share this. Start coding. No, that's not gonna work. Okay, we're gonna have to ask ChatGPT for this code. I don't know what else to say. So I need you. Let me look at the other code that the other AI gave me. This other code. Oh my god, it's so straightforward. Um. So particle spin. Okay, there's a function particle. You create a particle with spin. Oh, it's the same problem. It's just they also say spin up, spin down. So that's not what we want. So everyone completely misunderstands this experiment. Unbelievable. Unbelievable. Okay, so this is so simple. This is so simple. Okay, so when creating a particle, please choose a random angle. Keep it a secret when we call particle a dot measure, return up or down. Please choose. When creating a particle pair, please choose a random angle for one and the opposite angle for the other. Keep these a secret. When we call particle A measure, when we call particle measure, return up so when we call measure with an angle, we have to tell it at what angle we're measuring. Let's see if it can figure it out. This is, it's not so simple. To simulate, let's see if it does. I can tell you right away. This is the measurement angle. It's good. It understands the measurement. Good. There it is. Yeah, it's good. Where, let me see the creation. Entangled pair. Good. Good. Random angle. The other one is 180. But if it's more than 360, then just take the 360. It's very good. This is correct. This is good stuff. This is very good stuff. And do the plot. Run the test many times and do the plot. Run, allow running, allow running the test 10,000 times. Show the plot. Each experiment measure. So you do particle A measure 0 is equal to is up, is A up, is particle is up. If is up, then particle B measure angle increment angle by 1 degree each test. Here's the Python. All right, let's see this. Up count, down count. I don't. I guess it has to. Okay, trial. Then it runs. Okay, angle is up A. Is up A. Result B. Particle B measure. Good. So you see, is up A. It measures A. Is it up? For I angle if is up A. It should really do first. There's no point in this enumeration, but fine. Enumerate over the angles, whatever that means. Where's angle A 0 and angle B is A. This is very good. Let's see the plot. Can you show the plot? Alright, can we copy the code? Okay, collab, lab. Why am I not logged in? Am I logged in? Where's the user? There's no user in this thing? Okay, let's... How do you run this thing? Why is it taking so long? You know exactly what it's going to look like, right? This is going to look. I'm trying to recreate this, and I want to show that, of course, I'm going to get the red line. Of course, right? I'm simulating. A f- I'm not simulating quantum. I'm simulating what's given in a classical world, and I'm going to get the red line by hook or by crook. That's all I want to show. That there's nothing special in quantum mechanics, entanglement and schnanglement. It's all utter nonsense. That's all I want to show. And this is totally not what I expected, but you already see that it's curved. This is basically perfect. This is basically perfect. This is from 0. It ran to almost 180, and you see that it's exactly as predicted. Thank you very much. Nobel Prize. Another day, another Nobel Prize. So ridiculous. So ridiculous. This is atrocious. Absolutely atrocious. Disgusting that these people take a salary. Absolutely disgusting. Let's share this nonsense. What do you call it? This is quantum entanglement is nonsense after all. Quantum entanglement is nonsense after all. Congratulations. Share. Anyone with a link. Copy. Congratulations. Here it is. Have a great rest of your life. Let me see. Copy image. Here's the image. Have a great rest of your life. Let's write a paper. I don't even think we need to write the paper. Wait, did we do an audio test? Disgusting. I am disgusted. I'm kidding. I'm not disgusted. This is fun. Okay, audio sound. I
Sounds
am
good.
disgusted. I'm kidding. I'm not disgusted. I'm not holier than thou. Everything is fine. It's fine. Look, I'm an old man. It took me many years to become this brilliant. I was an idiot in the beginning, like they are now. Reload this page to apply your updated settings on this site. I don't know what that means. So it's fine. Everybody is an idiot when they're young. They're allowed to be idiots. So the story goes. Let me see. There's no one here. Let's share. Let's spread the genius. Everybody gets a taste of my genius. What are they gonna say now? It's like this is too much. You know what? Let me tell ChatGPT run it from 0 to 360 because I want it to look identical. Run the angle from 0 to 360. Mm. So I guess the angles is 0, 361, 1. So where's the angles? This is 360. Run it. Second run should be fast. LOL. So funny. Copy. He's gonna cry when he sees this. So this idiot, this idiot, this idiot. No, he's not an idiot. Uh, this this guy, this guy. Everybody gets one. Everybody gets one. Um. mhm. Tapioca Weasel gets one. Totoro gets one. Maybe we should go backwards. Who here needs this? Trucker, Gamma, Mordwand, Hover, Fligagigu, Spaghetti, Falkrami. Okay, let's take the code. So we already, if we go to mine, the paper, how do you copy the link? How do you just copy the link? What is copy message link? I don't want to copy the message link. Copy text? I guess copy text. I wrote a Python program to simulate this nonsense. It looks just like Bohr's weird prediction. LOL. Entanglement is nonsense. It does not exist. Who's this? Nick? The most important, oh, a moored one would like to see this. Gamma would like to see this. Totoro would like to see this. Shanji. The most important is Tapioca. I wrote a simple Python that reproduces The weird entanglement. LOL. Okay, who else? Let me put it in general. Along with, let me open the image, open image in new tab so I have it available to copy and paste. So ridiculous. No one has ever done this? I don't get it. What are they going to say now? It's like, now what? I don't need math. I don't need physics. I don't need anything. I asked ChatGPT. I gave ChatGPT the instructions. It's very straightforward. Done. What? Now what? Now what? Statistics, statistics, you have to do the mathematics, the rock notation, the bra, the cat, the schmed, the cat, here, okay, 10 lines, Python. Here, I reproduced your and the quantum entanglement. It's so weird. Only the weirdness of the spooky action in the distance can predict this, can reproduce this weirdness. Give us infinite money. Quantum computers, give us more money. You don't want to know the truth. You don't care about the truth. You have preconceived notions. This is so funny. It's so easy to defeat them. It's like, can it get any easier? Can it be easy? I cannot imagine crushing these numbnuts any easier. This is like easy mode. There's no challenge. Who's gonna challenge me? Why is my life so boring? Why is it so boring to disprove quantum mechanics, Bell's theorem, Bell's inequality? Give me millions of dollars. Quantum, it's weirder. It's weirder than we thought it could be. The universe. Give me a podcast. Invite me to the podcast. Invite me to your podcast. Give me millions of dollars. Give me more money. Ridiculous. This guy, he wants to measure the ether. He wants to measure the ether. Let's give him the paper to measure the ether. Where's my Google Drive? Google Drive. Drive. Se Google se Drive. Se Google. Se Google se Drive. Se Google. Se Google se Drive. How to resolve. Okay, gravitation, deriving black and theory. Wait, where? Oh, there is the experiment. Google Docs preview. No, I want to share, copy link. Okay. Totoro. Okay, you know what I can do? I can just, this is the whole point of the collab, is to be able to document it. So we can go to the collab and just add, how do you add a comment? Okay, that's how you add a comment. No, you don't want to add a comment. What you do is you add a section, add a comment like this. No. How do you add a section? Select cell, copy cell, explain code. How do you, oh, here, text. I wrote a simple Python, a Python. So this is 10,000. What if we do 100,000? Where's the number? It says cosine. Why do you say cosine? Wait, what? I don't want it to say cosine. That's not a good thing. That's not good. Shit. No. Okay, when you measure, you shouldn't say cosine. Why are you saying cosine? Measure angle. Calculate the probability of measuring out based on the angle difference. I think you have to say cosine. You don't have any choice. But this is cosine squared. I think this is literally Bohr. The whole point is that Einstein said it's not cosine. Radians, angle difference divided by 2. The angle difference is the absolute, the hidden angle minus the angle. This is the measuring angle. Good. It has a hidden angle. Nobody knows what the angle is. So you take the hidden angle minus the angle. That's the angle difference. I was too trigger happy. Copy link. Let me think. So this is the angle difference. The angle difference, that's fine. Then you take the angle difference, you divide it by 2. Convert to radians. Take the cosine squared. And that's the probability that it's up. But this is for A and for B. This is the probability of measuring up based on the angle difference. I don't remember why it's cosine squared. Why is it cosine squared? So it's cosine, that I already thought of, because if it's up and you measure up, you want to get 1. So that's fine. At 90 degrees, you want to get 50%. At 180, wait, the cosine at 1, the cosine at 90 degrees, let's see. Let's say the hidden angle is 0 and 0. 0 minus 0 is 0. So the angle difference is 0. 0 over 2 is 0. Radian 0. Everything is 0. The cosine of 0 is 1. It's 100%. It's good. That's at 0. Okay, what if the hidden angle is 180 and the angle is 0? So it's 180. So angle difference is 180. So 180 over 2 is 90. The cosine of 90 degrees is 0. 0 squared is 0. It's fine. What about, I mean, Einstein agrees with all these edge cases. That's not the problem. Mhm. Mhm. So the question is, let's ask ChatGPT why is it cosine squared? Each particle instance has a randomly assigned hidden angle. The measure method calculates the probability of returning up based on the cosine of half of the angle difference between the measurement angle and the hidden angle. For each experiment, one particle A is measured at fixed angle 0, and the other particle B is measured at an increment at changing angle. The probability of both particles returning up each angle and plotted at the end. This setup emulates the correlation pattern expected in quantum entanglement, showcasing how measurements at different angles relate to each other. Hmm. Um, let me. Um, it's based on. Let me copy. It's based on a conversation with ChatGPT. So here's the conversation. Oh, it's not gonna let me. So let me. No, no, it's okay. In the collab, I'll add the conversation in the collab. So I'll give you. Let me give you the prompt. Oops. How do you can't copy the prompt? Oh, that's ridiculous. Hmm. Text prompt. Here's the prompt. You can go take the prompt, it will give you the same output. And then let me copy text
I usually don't use Python, but I can read it.
Yeah, it doesn't matter. You can. It doesn't matter what language. Chat GPT.
See, Chat GPT is like it won't like work for me. I don't have a I can't like use it to graph shit out.
Why not?
Maybe I can use Copilot. I don't know.
Yeah, it doesn't matter.
It just
Any, just copy the prompt and you'll get the same results. So I just wanted to ask ChatGPT why it did the cosine squared. Why is it the co? It looks like the cosine. Let me ask you to explain. I can ask Gemini to explain this line. Where is the cosine line? No. How do I ask it to explain a line? I guess I would copy it. Thinking. Okay, let's break down this line of code. This line calculates the probability of a particle's spin being measured as up in quantum entanglement experiment. Here's a step-by-step explanation. In delta angle over 2, this part calculates half of the difference between the measurement angle and the particle's hidden spin angle delta. Okay, in quantum mechanics, this difference is crucial in determining the probability of a specific measurement outcome. This function from the NumPy library converts the angle, which is likely in degrees, to radians trigonometric. Okay, then cosine this. Okay, then the result of the cosine and then square. This is because the probability in quantum mechanics is often related to the which is related to the cosine in this case. In essence, this line. This is the most important line. Let's add it at the end. How do you add? Ugh, text. Wait. I want to copy. I want to copy the explanation.
you notice the angle difference, the cosine angle difference divided by two. Um, so this angle difference really matters, dude. Like so if you have like two angular momentum like vortices, right? And they're pointed in different directions, um the they're going to influence each other's spin. So I
No,
don't know if that really
no, no. There's.
yeah, if they're circulating in different directions and they touch, they're gonna change each other's spin.
Hold on. Let me. I want to copy over the Gemini, but Gemini is such a. It doesn't copy. This is so bad. Oh my god. Gemini doesn't know what it's doing. Let me. I'll be with you in a second. You're asking good questions.
Mhm.
I'm gonna ask ChatGPT. Why did you explain this line?
See, it's the cosine squared of the angle difference divided by two.
Yeah, why is it the cosine? It says, well, it's cosine squared because that's what usually we do in quantum mechanics. Which, I don't know. The squared cosine is a fundamental quantum mechanics for calculating probability. In an entangled particle system of probability, the two spin measurements will yield the same result, both up or down, as given. It's it doesn't really matter. It's like, why is it important? Why is it important? I mean, I don't care. I don't care. I mean, there's no spooky action at a distance. I didn't tell. I
Oh,
didn't tell. I didn't tell the, what do you call it, ChatGPT. I didn't tell Python to communicate between the two particles. There's hidden variables. It's literally called hidden angle. It chose the
yeah,
name. It called it hidden
yeah,
angle. So it's a
yeah.
hidden. That's it. There's a hidden variable, and if you
Hmm.
square you square the cosine of the hidden whatever, you get the right answer. What do you want? That's it. That's it. That's it. It's literally hidden variable with a cosine squared does the job. Have a great rest of your life. Roll the credits. We're done. I love saying roll the credits. I'm sorry. It has become my favorite line. Like, I always roll the credits. Roll the credits. Oh my god. Poor Einstein. He didn't have ChatGPT to help him. He had to face these buffoons on his own, and like he just got tired of them, and he said, "You know what? Yeah, a day will come and a guy, some other guy is gonna explain this to you. I'm out. I'm signing out. Too much
Hey,
none. Yeah.
so wait a second. So, compound angle, that just means that you have more than one angle, right?
Let me see. Let me see. So you're looking at the collab. You're at the collab.
So this is what I'm looking at. Okay, good. Cosine 2x is an important trigonomic function that is used to find the value of cosine function for the compound angle 2x. So there's like two angles. Is that what that means?
No. So the story. This you can read the prompt. Let's go to the prompt. You see at the end the prompt. Let
Are you
me
on your YouTube channel?
let me it's gonna be a little bit difficult because if I'm here and there, it's gonna be let me try and share it. Let me try and share it. Quantum entanglement is nonsense. It doesn't matter. Look, it honestly does not, nothing matters. The point is that there's no need for entanglement. The word there's no need. There's no need. That's the point. You can
Hmm.
separate the two particles. Each has some hidden variable. And when you do the measurement for each one, you get the right answer. There's no need for instant spooky action at a distance. There's no need for the two particles to communicate. That is the whole point. That's it. You don't, it doesn't matter if it's cosine squared, cosine to the fourth, cosine divided by the tangent to the sixth. But it doesn't matter. The point is there's no need for entanglement. You don't need to entangle them. They don't need to communicate, to commune. They don't need to have ESP. They don't need to have to communicate with each other at instant across the visible universe and nonsense like that. That's the point. It doesn't matter if it's cosine divided by the sine times the tangent times the cotangent times the inverse natural log to the seventh degree. I don't care. I don't, it doesn't matter. The point is they don't need to communicate with each other. That's the point. I don't care what calculation you need to do to get the right answer. That's not important. It's whatever. It's because of this, because I don't care. The point is, you don't need to entangle them. Once
Hmm.
they've been created, you separate them and you measure them each separately, and they have nothing to do with each other. And you get the
Hmm.
graph as Bohr predicted.
They also people also say like if you change one, the other one will change too. It's not just if you separate them and
That,
then measure them, but if
it
you change one.
no, if you no, no, no one says that. You can't change anything. when you measure one, look, you can measure one of them. Look, whatever people say is nonsense. Like I don't care what they
So
say.
you, when you measure it, you're actually changing it, right? Like,
No,
well, okay, so
no,
um,
no, you're not. When you measure, nothing happens. You just get the answer.
mhm. Well, I mean, like people are claiming that it's not just like you separate them and then they have some kind of, state that they left with and they're keeping on to it. They're saying that if you actually change one, then it'll change the other. Is that just a correlation or is that a real causation?
No, no, no. Ignore what everyone says. Go with what do you say?
Well, the problem is that everybody's not clear and they don't explain their measurement apparatus, so I can't really trust them because there's so many, you
So
know,
ignore the universe.
there's too much lying.
No,
There's too much lying from these
no,
people, so I can't really.
no, no, no.
There's too much
It's not
like
important.
hidden motives.
It's no, no. You don't need that. You don't need to go so far. No, we don't need to go that distance. We're not over there. That's not where we're at. They're all as confused as you were at the beginning. Only they're getting $1 million a year and you're not.
By perpetuating the illusion or whatever.
No,
Like I just
maybe
don't get it. I
it doesn't
like it's
matter.
wasting my time. Like I
It's
wish they would
it's
tell
fine.
me what the fuck's
It's fine.
their
It's fine. It's fine.
the
I think I'm done with entanglement. I think I figured it out. I mean, this is eh, as far as I'm concerned, we're done. So ask
Mhm.
me any question you want, and I'll hopefully be able to explain anything you want. So let me just I am sharing. Oh, it's gonna be tiny. It's gonna be. Let me see if I can make it a little bit bigger. Okay, can you see my stream? Can you see it? I'm streaming
um
the thing.
yeah, I can
Oh,
see it.
okay.
Mhm.
So let's go. Okay. So what are we doing here? We're saying so class particle, right? We're creating a particle. It's given an angle, and it saves the angle as hidden angle, and no one knows what it is. I never tell anyone what the angle was.
It's just randomly initialized,
Yeah,
right?
yeah, of course it's random, and the one is opposite the other.
Okay.
Okay, the next step is measure. So particle has a method or a function called measure, and in the measure you tell it at what angle you want to measure. So particle
Mhm.
A will always be measured at 0 degrees. This is the
Gotcha.
way I'm running this experiment. So we take every time we create two particles, we give them random opposite directions, angles, and then
Mhm.
we take particle A and we measure it at 0 degrees. Basically, we're asking it, are you up? Are you pointing up?
Mhm.
If it's pointing up, then we run the experiment on particle B. Particle A, we're
Mhm.
done. We're finished with it. Now, the fact that it says that particle A is up, what do we know about its angle? Can you tell me? What do we know about the
It's
angle?
0.
No, no, it's not. It
Oh
could be.
wait, particle.
It could be
Oh,
0. Particle A, we ask it what is, or we run it through through the magnets, and it goes up. What does it tell us about its angle? But the hidden angle. The hidden angle must be between
up
something and something.
or so uh it has to be greater than probability up,
No, an
else it's
angle.
down, right? Oh.
Look, so if you're if the magnetic field is pointing up and
Mhm.
the particle is pointing up, then what is the particle going to do? Is it going to go up or down? If the magnetic field
It's,
is pointing up, right? You're running the particle
I think
through.
it points down, right?
No, it. So if the magnetic field is, I don't. It doesn't matter. Let's assume if the magnetic field points up and the particle points up, then the particle goes up. Let's assume that,
Oh, okay.
okay? And the
Hmm.
opposite, if the particle is pointing opposite the magnet, let's say the particle is pointing down and the magnet is pointing up, then the particle will go down.
Oh, okay.
If the particle is pointing to the right and the magnet is pointing up, what is the particle going to do?
Mm. Okay,
So
so if the
in that case, it's
oh,
going to do 50-50. 50% of the time it will go up, 50% of the time it will go down.
oh, okay, got you.
And the same for if it's pointing left. If the particle is pointing left and the magnet is pointing up, what is the particle going to do?
50-50.
Exactly. Now the trick is, what is the particle going to do at 45 degrees? Like if it's between, I need to let's assume to the right is zero. Let's start. Let's say to the right. No, because the experiment says up is zero. Up is zero. So to the right is negative 90 degrees. It's very confusing. Let's use the clock. So 0 is 12 o'clock, right?
Hmm.
Up is 12 o'clock. So let's say the particle. So if the particle is pointing to 1:30 o'clock, 1 o'clock and 30 minutes, that's exactly between 1 and 3.
Hmm.
What?
And it's and
Yeah.
the
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 the magnet
magnetic
the
field
magnet is
is
the magnetic field is 12 o'clock. It's always right now we're talking about particle A. The magnetic
okay.
field is always going to be 12 o'clock in this for particle A. So
Okay.
so the magnetic
So
field
in the
is 12 o'clock. The particle is at 1:30
particle,
o'clock. It's between 12 o'clock and 3 o'clock. It's exactly halfway. It's 1:30 o'clock. What is the particle going to do? So we said if the particle is at 3 o'clock, what did we say?
that I don't know. I
Wait,
can't remember. Okay, so
you
I
can't.
don't know the left and the right and the up and down from the clock. So 12 o'clock
12
is
o'clock
what?
is noon. It's up.
It's up. Okay, got you. And
And,
so if we're
and then you
pointed
have
towards the right,
1 o'clock, 2 o'clock, 3 o'clock is to the right.
okay.
4 o'clock, 5 o'clock, 6 o'clock is down. Yeah?
So it would be
Let's just finish the cycle. 7 o'clock, 8 o'clock, 9 o'clock is what?
left,
Good. 10 o'clock, 11 o'clock, 12 o'clock is
left and up.
12 o'clock. What is 12 o'clock?
It's up.
Good. Very good.
Six clocks down.
Yes.
So 1 o'clock,
1:30 o'clock. 1:30 is
1:30 o'clock.
exactly between 12 o'clock and 3 o'clock.
Hmm.
So if the particle is pointing at 1:30, what will it do if the magnet is pointing at 12 o'clock?
It will. I guess it will go more right more of the time, right?
No, it never goes right or left. When the magnet is 12 o'clock, then the particle will either go up or down. It never goes any other direction. The particle can only go up or down because the magnetic field is up and down.
Got it. Got it.
So it doesn't matter
So
what
it's
it doesn't matter
well,
the
it's closer
direction.
to
Yeah, go ahead. Hmm.
It's it's closer to 12 o'clock. So
No,
would that be the
it's exactly halfway between 12 o'clock and 3 o'clock. So we already resolved what happens at 12 o'clock and 3 o'clock.
Mhm.
Namely, what happens at 12 o'clock if the particle aims
It's
is
up.
good, and if the particle points at 3 o'clock?
It's 3 o'clock, right? I
Yeah.
have no idea. It's a halfway in, but well, it's not. It's like I guess
Well, let's go to 6 o'clock. If the particle is 6 o'clock and the magnetic field is 12 o'clock,
so it'll be down.
exactly. But in this experiment, we're asking the particle A, are you up? That's the question. Because
Mhm.
only when A is up are we asking B questions. Like every time A is not up, we don't conduct the rest of the experiment. We go to the next particle.
Got it. Got it. Because
Anyway,
that's definitive.
well, that's the way we were running the experiment. That's the way Don Lincoln explained it, and that's the way apparently everybody runs it. So I don't care. Anyway,
Okay.
so the question is,
Because if it's at zero, it's
no, don't say
when you do
zero.
the rant.
We don't know
Oh
what.
wait, well I
Say
mean
o'clock.
12. 12.
Okay, yeah,
So when you're at 12 o'clock,
the
it's
particle,
basically the up measure, which is
the particle or the magnetic field.
um the particle. The
Okay.
particle.
Hmm.
And so if it's at 12, it's at zero, right?
Don't say
And
zero.
so okay. Oh wait,
Yeah, it's very confusing. I mean, I'm so sorry. I don't know what to
well
tell
I'm
you.
talking about I'm not talking about the spin up, but I'm talking about the probability up. So the probability up, if it's at zero, then it's a certain probability up. So you go to the next particle.
Look,
Or
the
it's a
the
certain
the
spin
point.
up.
You know what? Okay, I'm not gonna be so lazy. Where's the whiteboard? Let's draw it on the whiteboard. We have no
Mhm.
choice. Entanglement is nonsense. Okay. Jesus, it's raping my eyes. Jesus Christ. I'm sorry. I'm sorry for the eye rape. Okay.
Which
Yeah, sorry.
that's all right.
So,
I can't scroll out. My fucking mouse wheel's
no,
broken. Is
just
there
watch
another way to scroll out?
watch my stream. You should be able to see it on my stream, no? You can't see it on my stream?
No, I just see the quantum entanglement is nonsense or the script.
No, no, no. Go to my YouTube channel.
Okay.
Is nonsense or the script. No, no, no. Go to my YouTube
YouTube,
channel.
Mr. Slave.
Let me try and get you the link to my to this stream.
I got you.
Okay, I'm gonna put it here on the side chat either way. Okay. So, alright, so what are we saying? Oh, come on. So, so let's imagine, so we're gonna say that, so when the particle is spin up, and the magnetic field, right? In for particle, we're discussing particle A. Particle A, the magnetic field is always up. Fine?
Mhm.
So far, so good? Are you with me?
Mhm.
Let me get this. Oh my god. Forget it. Let me start over. It's too messy.
So
Uh,
basically, if they're both
mhm.
up, then A is always going to be up.
No. So the magnetic field. So for A, the magnetic field is always up. So if particle, so if particle A is up and the magnetic field is up, then we're gonna get a result up.
Mhm.
If A is down and the magnetic field is up, then we're gonna get well when we said okay, we're gonna get down. I mean the or we're gonna it's gonna be no. This is gonna be yes because we're asking is it up? We're asking
Mhm.
is it up? This is the question. Is A
And
pointing up? So
okay.
it's yes. If it's pointing down, then it's no, obviously. If it's pointing to the right, if A is pointing to the right,
It's a 50-50.
exactly. It's 50% yes.
And so like as you like shift radians up or down, then it's a ratio of the radians.
I'm
So
not
like
I'm not
if you're
thinking we'll come back to the code. First of all, let's talk about what
okay.
we know. And and what happens when it's 45 degrees? If it's 45 degrees,
It's 25-50 or 25-75.
so you would think that, but it happens to not be. It happens to be, I think it's 1 over the square root of 2 or something, or 2 over the square root of 2. I don't know. It's
Mhm.
it's the cosine squared of the angle of 45 degrees. So 45
Okay.
degrees, I think, is 1 over square root of 2. I don't know, some number. It's like, it's close to 25%. I think it's 12% or something. I don't know.
Uh-huh.
It's cosine squared. It's whatever. It's whatever. It's some number. It's not 50%. It's not 25%. It's cosine squared.
Mhm.
Why is it cosine squared? That's not important. It's
Oh.
this is the way it works. There's some mechanism, but this is not entanglement. It's not that it depends on the other part. I'm not telling you it depends on the other particle. I'm telling you there's some equation, for some mechanical reason. This is what ends up happening. That it's this is the equation. It's a mechanical
Mhm.
reason. It doesn't depend on the other particle. Now, everything I told you about particle A, it's basically the same for particle B. Only the magnet for particle B is we're going to change it every time we're going to change it. We're going to measure angle 0, and we're going to measure at 360, and we're going to measure at 180, and we're going to we're going to each time measure a different angle where 0 is
Mhm.
up, let's say. So we're going to measure up, and then this angle and this angle. The magnet, we're going to change the magnet each time a different plus one, plus one, plus one. Every time we're going to change it by 1 degree. So we're going to run around 360. And we're going to run this test 10,000 times. So we're going to
Mhm.
do this. So it's 10,000 divided by 360. I don't know, 10 times. It's about 100 times. So we're going to run a
Mhm.
test 100 times for 100 times that we get for, right? So let's say 100 times, whatever, how many times we get A going up. Okay. Let's run the test. B pointing up. A pointing. A is up. Let's run the test. B pointing up. And this we're going to do 100 times. And then we're going to shift to angle a little bit to the left, and we're going to continue the test. A, is it up? Yes. If it's up, test B at 1 degree. And the plot,
So
let me just
when
finish.
you rotate the
Let
okay.
me just finish. The plot that we got is this. And this is exactly the plot that they get in the lab with the quantum entanglement. The quantum entanglement. Without quantum
Mhm.
entanglement, I get exactly the same result. I didn't tell Chad. If you look at the code, there's no quantum. I'm not delivering. I'm not sharing information between the two particles. There's no faster than light communication. There's no instant communication between the particles. Actually, there is no communication between the particles. There's literally a hidden variable. And the hidden variable gives me the result of the entanglement. The entanglement.
The hidden variable is like this cosine bit,
No, that's
like a
not.
cosine
No, it
squared.
does. No, the hidden
It's
variable.
mimicking something.
No, 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 no. It doesn't matter. That's not the point of entanglement. The hidden. You see the hidden angle. You see where it says hidden angle.
Hmm.
That's the hidden
Yeah, it's a
variable.
random angle.
Yeah, but that's the hidden variable. We don't know what it is. I never show
Uh
it.
huh.
I don't care what it is. That's the
Yeah.
hidden variable. That's how Einstein said it's a hit. There's a hidden variable. That's what he said, and they said it can't be. It can't be. The universe is multiverse. It can't be. And Einstein said, no, no, no. Trust me. There's a hidden variable. It's going to explain everything. Until he
Hmm.
gave up on these Looney Tunes. He said, you know what? These people, I'm not going to deal with them. Let somebody else deal with them. He waited for me to deal with them. For me, I eat these people for breakfast. You know, Einstein wasn't designed for taking on these nutcases. For me, I grew up. I grew up in the hell of Mount Doom. That was my birthplace. So I can deal with them. Einstein, he was too frail for these numbnuts. Anyway, so Einstein was right. If you just have a hidden angle, everything works out. All you need to do is this cosine squared. But it doesn't matter. Don't let the cosine squared scare you. That has nothing to do with entanglement. The point is that the particle doesn't need any information from the other particle. There's no need for any communication. Let's go through the code. Okay, so angle difference is some angle difference. You need to do the difference, and then you calculate the probability on your own. You see, there's no communication. The hidden angle, the particles don't know what the other guy measured. They don't
Hmm.
know. B doesn't know what the result was for A. B doesn't know that only when A is measured up, we measure B. We did. B doesn't know. B doesn't care. When you ask B, are you in this angle, right? Because every time we don't ask it if it's up, we ask it, are you at this angle? 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 We keep asking it, are you at this angle? Which means with the probability stuff. It's not are you exactly. We never ask it are you exactly. We tell it,
Yeah.
look, the magnetic field now is at 10 o'clock. What say you? So it flips a coin. When we ask it, it flips a coin. Does it?
Hmm.
Yes.
I don't
Yes.
think so.
Look at the last
Well, I
line.
mean, you bump it and you
Look.
disturb it, and
No,
then
look
it
at the
does
last
something different.
line. Look at the last line. You flip it.
Okay.
It flips a coin. It
Well,
looks at
that's
the
the math, but not physical reality. Like the
It
probability, if you're
doesn't
less
matter.
than the probability up.
It doesn't matter. It doesn't matter. It doesn't matter. There's no. It flips a coin. If the probability is up, it flips a coin, otherwise it's down. But it flips a coin,
Mhm.
random. It flips a coin.
It flips a coin relative to the statistics of real
Look,
world
let's read this.
detection, right?
Look, it says here return up if random is less than probability up, else down.
Mhm.
So probability
Okay,
up, let's say probability is usually between 0 and 1.
right. So if
So
that value is at the same
let's assume
rotational angle
let's
as
assume
the
let's
magnetic
assume
field,
listen.
then
Let's
it's
assume
always up.
listen.
Okay.
Let's assume random is between 0 and 1. I don't know what random is. Let's
Hmm.
assume it's between 0 and 1 and probability up is between 0 and 1. So now it's
Okay.
50-50, right? So if random is less than probability up, look, it doesn't matter. It's some flipping of a coin.
Oh wait, yeah, yeah. I see what you
It's
mean.
some flipping of a coin. It flips a coin. It doesn't.
Hmm.
It calculated the probability, but this is irrelevant. It doesn't matter. The point is, there's no communication. There's no now. Now this is also true. This code measure. This is true also for particle B. But
Hmm.
we all we tell B is in what angle we're measuring it, and all it's using to give the answer is the angle and the hidden angle. At what the angle is the magnetic angle, and the hidden angle is its own angle, and it comes
Hmm.
up with some answer. And the answer, when you
Hmm.
plot it, looks exactly what it looks like in the lab, what they call entanglement. The particles must be communicating. They must be communing. They must be sending signals across the visible universe at the instant. They're violating locality. They're violating reality. But here you see, I don't need to violate anything. I'm not violating anything. There's no violations. There's no communication. It's a simple calculation.
But if it's always relative to that magnet's orientation, what the particle A will do, um, there's some kind of communication going on.
No, no, particle B, there's no code, there's no in the code of measure, there's no information. I'm only using the hidden variable. It's just all the information that particle B
Wait,
needs. Mhm.
you're
Go ahead.
using the hidden variable with the probability up calculation.
That's fine. It doesn't matter. I told you, I can do anything I want. I'm allowed to do anything I want inside the function measure. As long as I don't use any information from particle A or from the measurement of particle. I don't know anything about the measurement of particle A when I call measure in the function measure. There's no information about the measurement of A, about the angle of A. Particle B doesn't know anything about the rest of the universe except for its own hidden variable and the angle of the magnet.
Yeah, but the magnet is another system.
But it has nothing to do with the other side of the universe where particle A lives and supposedly is sending it some information. Particle A
So
is not. Go ahead.
you have self hidden angle minus angle.
Mm.
So you have the hidden angle minus another
It
angle.
doesn't
What's
matter.
the
But
other?
the
Oh,
other
it
angle,
is the angle. Okay.
that's the magnetic. The angle is the magnetic angle, the angle of the
Okay.
magnet.
Gotcha.
This is
So
fine. This is terrific. This disproves once and for all entanglement. Say goodbye to entanglement. Goodbye entanglement. Goodbye. Goodbye. Good riddance. We're done. We're done. Done with nonsense. No more nonsense. Look.
well, what I'm saying is the transformation of the
hmm
spin state
hmm
is taking in the angle of
There's
the
no
magnet.
transformation. Wait. There's no transformation. There's measurement. We're
The
only
probability.
measuring the hidden angle is never
Because you're doing
changed.
angle difference.
That's fine. It's fine. It's some
Is that a
It's okay. I'm
okay?
allowed. I'm allowed to do anything I want as long as I'm not communing between particle A and particle B, or between the test of A and the test of B. There's no communication. All I have is just I ask particle B, please measure yourself based on what you know about yourself and what I'm telling you now about the angle of the magnet. That's it. That's it. That's allowed. The only thing
Well,
that
the
Go ahead, go
the
ahead.
angle of the magnet,
The
the
angle,
angle of the magnets
yeah.
having a consequence on the spin state of the
y- What? What other
other
what?
particle
No,
or the
not the other.
particle.
No, the other particle, particle A, is already been destroyed. It's already been measured. It's gone. It's in the garbage. We don't care about particle A.
Okay.
Now we're talking. Now we're particle B. The function measure is both for A and for B. For A, it's simple. Now we are B. B, you see, all that B needs for the function measure is its hidden variable and
Okay.
the magnet angle. It doesn't need
Well,
any
let's
info.
just
Go ahead.
let's say we have access to the angle, um, and then we're subtracting it to get the angle differential
It
in
doesn't
a
matter. It doesn't
you know
matter. It doesn't matter.
modular
You're
360.
allowed to do any calculation you want within particle B and the instrumentation around particle B. You have to assume particle A is in one side of the universe, particle B is on the other side of the universe. So they cannot communicate. Now,
Okay.
the
Then
claim,
how is it affecting the probability though?
but it's not. This is my whole point. My whole point is that there's no entanglement. There is no influence. Particle A doesn't influence particle B, but we get the exact results that they got in the lab. You see, my graph tracks exactly one to one the graph they got in the lab, where they say, oh, entanglement. Only entanglement can give this result. And I say, no, I reproduce your entanglement without entanglement, black on white. I
Can you
reproduce.
help me understand something?
Go ahead, no, but of
So
course.
so so how is it that the
Mhm.
angle difference is not a objective measure of some kind of interaction?
How? What? Show me the
Because you're
information.
using that
Show me
you're
the
using the
what? I'm using what?
there's the angle difference, so you
That's
got the
fine.
absolute value of the
That's
hidden
fine.
angle minus the magnet
That's
angle.
you can do anything you want. It doesn't matter, right?
I don't see
No, but what
but it does matter
you
when
know?
calculating the probability of
No,
up, or I mean,
no, no,
not calculating probability, but
no,
determining up or down
no. Look, you have to understand
by
what.
the random number.
No, you have to understand what is this experiment about. What are we experimenting? What are we testing? We're testing entanglement, nothing else. We're
Mhm.
testing, is particle B receiving any information from particle A, or from the test apparatus of particle A, or from the result of particle A? Is any information being delivered to particle B? When it comes time for particle B to make a decision, is it up or down?
Well, I guess it's the angle differential is taking in that.
No, but that's not between, that has nothing to do with particle A. There's no information that I'm delivering from particle A to particle B. There's no information. I'm not delivering any
There,
information. Particle B
there's no angle differential.
between A and B? No. There's B. You see the code in B. The code of B is three lines. The code of B is the function measure is three lines. The angle difference, that has nothing to do with A, the probability, nothing to do with A, and then the actual, is it up or down, nothing to do with A. There's no information from that side of the universe of
Wait,
A.
but probability. Wait a second.
Hmm.
Probability
Hmm.
up
Hmm.
takes in cosine of radians
It
angle
doesn't matter.
differential divided by 2
It can do anything. Look, you
to
have
the
to,
power of 2.
fine, but you have to understand what we're testing. It doesn't matter. There's no information, right? The whole test is, are we sending information from A to B across the visible universe faster than the speed of light? That's the question. They're claiming Bohr and his numbnuts are claiming that information is delivered from that part of the universe of A to that part of the universe B. And that's the only way to get the graph they got. And I say, well, here I got the graph you got, and I didn't share information between A and B. Conclusion, there's no entanglement. We don't need entanglement. Entanglement is nonsense. We're done. We're done. It's history. It's another chapter of nonsense, like many things in history. It's behind us. We're done. People will listen to our conversation and will not believe what they're hearing. For 100 years, the scientific community believed in this nonsense. For 100 years, they gave a Nobel Prize for this nonsense.
Well, I mean, what your calculation is still taking this differential, and
It's
that's what I
fine.
don't
That's
understand.
but it doesn't matter. It doesn't matter. I can write any algorithm in measure. In the function measure, I can write any algorithm in the universe. It it it's not it has nothing to do with this, with the contention, with the proposition. The proposition is that in order to reproduce their graph, their plot, we need to allow communication between particle A and particle B.
Mhm.
And I show that I'm able to reproduce their plot without the communication. It doesn't matter how I'm doing it, as long as I'm not communicating from A to B. I don't care what A did. I don't care what happened to A. It's irrelevant. I'm only doing B. And I'm giving you exactly as expected. Exactly what they got
Oh,
using entanglement. What they
oh, I
got,
think I see what you mean. I think
the
because
plot. But listen,
because the
yeah, go ahead.
so the up value is really um a correlative measure with the angle differential. It's not like a direct communication. It's just
There's
like,
no communication. Look at the code. When you call B, when you ask B to measure itself, B doesn't
uh-huh,
talk to A. B doesn't care what happened to A.
got you.
I don't know what else
Because
to say. It's slam dunk. It's open shut case. I don't care, and I don't
Mhm.
care about the math. I don't care about the cosine squared. I don't know what cosine squared is. I don't know what is 1 + 1 = 2. I don't know. All I know is I can reproduce their plot without sharing information from A to B. That's all I need to
Mhm.
know. That's it. What is being done within B, within the knowledge of B and B's apparatus, I don't care. I don't care
Mhm.
because I'm not doing what they said that needs to happen. They say that there needs to be communication from A to B in order to reproduce their plot. And I'm saying, and I'm showing incorrect. I reproduced your plot without sharing information from A to B. That's it.
Do they have any valid experiments?
Of course, I
Is-
mean, of course, I have
Can
experience.
we see those?
That's the argument I had last night with the Pioca weasel. Sure, I mean that's the previous comments on the. Here, watch my stream.
Uh-huh.
Here it is. This is it. This is from, you see, Fermilab. You see at the bottom right angle, the bottom right. This is the logo of Fermilab. This is Fermilab. They're saying
Do they have any?
the black,
What's their experiment? I
the
need to know
black,
the details of
the
the
black,
experiment.
the
I
black
can't.
dots. The black dots is the experiment. They say that the blue lines is what
No, I need that's not what I mean by experiment. That's not,
it
you
doesn't
know, because
matter.
I need to know whether I need to know the actual distribution, three-dimensional distribution of the actions
No, there's
and
no. What do you mean?
distance.
Mm,
Like I
What
need
do you
to
mean?
know
What do you
how
mean?
they're doing the measurement. I need to know how they're doing it in the real
The
world,
actual,
given
the
three-dimensional space
the actual
and
appar-
speed over length
the actual.
and all that. So,
You want to see the actual apparatus?
yeah, because this is not an objective measure. This is just a second order,
What are you
you know,
talking about?
probability
I never.
calculation.
What
I
are you
need to
talking
know.
about? I don't know
I
what you're
need
talking.
objective,
I
real
don't know.
world grounded.
It doesn't matter.
So I need to know.
Okay,
Listen. I need to know if
what?
they did actually detect this.
It doesn't matter. It doesn't matter. It honestly doesn't matter.
It does matter
No, not to me.
because I don't know if it's real or not.
No,
I can't
I
know if
don't
it's
care.
real. Anybody can write a mathematical
I
equation.
don't care. I don't care. I don't care. It's not to me. It's not important. I'm not because I'm disproving them. I'm saying
And
everything they.
also, there could be problems in the measurement apparatus too, to where
I don't
their core
care. I don't.
they're taking their
It's.
correlation
I
as a
don't.
causation.
I don't care.
So there's a lot of things that I need to see
I
in
don't
real time.
care. I don't care. I disproved their contention. So everything else doesn't matter. You
Well,
might. It doesn't
I can't
matter.
follow where
Look,
you're at
somebody.
if I
Look, somebody tells me. Somebody tells me. I pooped, and I tell him,
Mhm.
and I tell him. What do you?
Yeah,
Let me try.
I pooped at this angle or whatever. I don't know.
Let me try and think of an analogy. Um,
Mhm.
the point is, they're saying that they were able to get a plot only through communing, only through uh, talking to the dead.
Yeah,
They
that's
s-
awesome. I need to see the experiment.
okay, fine. So I say here I can reproduce your plot without talking to the dead. Here,
Yeah,
ChatGPT
but that's
or
not it.
the
I need to
Python.
see their experiment.
I don't
If
because
you produce
you don't because I disprove them.
this is not an objective measure. I need to see the
No, you
experiment.
don't need to because I disproved them. Why do you need to see something that I disproved? Again, listen, they say the only way we can get this plot is because we commune with the dead. And I say I can reproduce this plot without communing to the dead. So you're lying. Either you're lying or you're an idiot or I don't care. I was able. You said the only. You said your evidence. You said that I have evidence. I talk to the dead. What is the
Yeah,
evidence?
you're
Listen,
using terms like
listen,
communing with the dead. They're using
listen.
arguments like communing with the dead. But what I want to see is the fucking
It it
experiment.
doesn't
That's
matter.
what I want
Okay,
to see.
listen. A guy,
If there's no fucking physical experiment that I can see, I can't make judgments.
listen. A guy, right? There's these guys on television. They say we can talk to the dead, and they have an audience. Have you ever seen that with the audience? And they can talk to the dead. You have
Yeah.
somebody in your family. Her name
But
is.
that doesn't matter. That's
Listen,
not experiment.
listen.
That doesn't
Yes, it
matter.
is.
That's not
Yes, it is.
experiment.
Yes, it is. Yes, it is.
I need the
Yes,
experiment.
it's
I
an
don't give a shit about
it's
that
an
graph until I
experiment.
see the
It
experiment.
is. It
But
is.
I need to see it.
It's
I
an
need to
ex-
see it and I need to know the
shush,
controls.
shush. I heard you. Let me talk. Let me talk. So you
Okay.
so these people they come on live television in front of an audience and they say, wait 1 second, we have a comment from Stoic Mindset. Let me just respond
Mhm.
to the commentary, the comment section.
Okay.
Oh, and also we have Dennis Volker, a new guy. Is the entanglement not the communication, so time becomes the variable? I don't know what you mean. Um, Also, Stoic mindset. In light of recent developments and the overarching necessity to align our forward-looking, yeah, he always just spouts nonsense. Um, I don't know. This is from 45 minutes ago. I don't know. I don't. Oh, there's 4 people watching us. That's nice. That's very nice. Okay, so look, so you go, so you see on television. I've seen these people, and I used to believe it. There's these people on television, they come and they say, I talked to the dead, I talked to the dead, and you're in the audience, I feel you have a family member, it starts with an N, and it starts with an N, and they respond, they say, yeah, I have a grandma, she just died, her name is Nancy. Nancy says that she left you the candles burning, candles. And the woman says, yeah, yeah, she used to love candles. Yeah, and she says she loves you. Anyway, so yeah, it looks like he's talking to the dead. And then another guy comes in and he says, look, I can do the same without talking to the dead. And he does the same without talking to the dead. So now do you need any more information? No, the first guy never talked to the dead. He pretended to talk to the dead. And if you train enough, you're able to fool people. You're able to play around. You're able to read their faces. You're able to read the audience. You're able to play games. That's it. People do this all the time without talking to the dead. And then that's it. And there's plenty of these. I can bend spoons. I can bend spoons. Yeah, go to the shop and go to the where they sell magic tricks and tell them you want to buy a spoon that you can bend, and they sell you a spoon that you can bend.
There's a problem with these measurements. They're sending the photons in the same general direction in a
No,
like
this no no.
it's
It doesn't matter. Look, it doesn't matter. It doesn't. If photons, electrons,
that does matter.
no
They
nothing.
need to go in the opposite directions if you're going to
No
measure entanglement.
no.
I need to see a
It
measurement
doesn't.
apparatus that
It
sends the
doesn't
particles in opposite
matter. It
direction.
doesn't matter. Whatever their
Yeah, it
whole.
does.
Listen. Shh.
It does
Li-
because the
shh, shh,
fucking
let me
photon
talk.
is an
Let me talk.
energy impact on that meter space.
Stop,
The,
stop with your nonsense. Look, it doesn't
and that
matter. Let me talk.
spreads out.
Let me talk 1 second. Look, whatever
Mhm.
whatever they did, their whole claim to fame is that it only works because particle A communes through the infinite vastness of space instantaneously with particle B. And that's the
That's
only
why we need to see the experiment.
listen, let me finish. And
Mhm.
that's the only reason they got the plot. That's the only way to get the red line in the plot that we're looking at. And I say, oh yeah, let me try and reproduce your graph without allowing particle A communing with particle B. And done in 2 seconds.
And, yeah, but
So
you took in the angle differential.
so that's allowed. They said the only way, listen to what they said. They said the whole claim to fame is particle A. The only way they got the plot is because particle A communed with particle B. And I say,
This is the
hold on
problem.
one second.
We're
Let me
gonna be
finish. Let me
arguing
hold on.
with
Oh,
analogies
wait. No,
and
there's
we're
no
not gonna see the
no.
experiment.
No, this is not an analogy. Look,
We're not
let,
doing
let me just finish. Let
physics.
me just look. You can go and look at all the experiments that they did. It doesn't matter. It doesn't matter. I disproved
That
every.
graph, look, that graph is an analogy. I need to see the real experiment.
I don't think this. I don't even think this graph is an analogy.
That's an analogy. I need to see a real
I don't.
experiment.
Fine, go look for it. I don't care. You left a comment. I don't mind. Look, go find the actual lab experiment. I don't care. I don't mind. You if you feel that you need, I have zero respect for this experiment. To me, it's dead to me, as Mr. Wonderful says. I'm on the phone either way. I don't know what's the big deal with the. Oh my god, this is so funny. Many a crackpot. Many a crackpot has inspired this musical number. I think you're leaning towards it, not about a label. It's about being able to. I don't care how I am labeled. Okay. Any questions? You wanna go through the code? Let's continue looking at the code. Are you there?
And see, when you use like cosine and it doesn't have an explanation of physical grounding, that's another thing. Like when you use like numbers that don't like reference, a physical property, it's not gonna like convince me of anything. It's like you don't have a physical basis for that parameter, you don't have a physical basis for that parameter. It's like I need the
It
physical
doesn't,
basis
but it
of that
doesn't.
parameter,
It doesn't
because
matter.
math is
It
analogy.
doesn't matter. It
Is
doesn't.
it's an
It's not the
abstract
point. It's
analogy.
not the point. Oh my god! It's not the point.
Because think
Not.
about it,
It's
like
not. It's
if
not. I
if
know. I know. I know. You don't need to explain. I'm on your side, but in this case, it doesn't matter. You're the last. I'm the last person you need to convince that math doesn't mean anything. That math is BS. You don't need to convince me of that.
no one said that, no one said that.
It doesn't matter. I
I told you,
agree.
I said it was an
It's
analogy. It's
fine. It's
mapping
I
onto
don't care. I
something.
don't care. It doesn't
Listen,
matter.
listen, listen. No, 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 no. It's an analogy. It's mapping onto something, and I need
It
to know what it's
doesn't.
mapping
It
onto.
doesn't matter. It doesn't matter. It doesn't matter. Math is some
It does
algorithm.
matter.
It doesn't matter. It's not for this. Not in this case. In this case, all we're saying is that we're running some algorithm, right? At the end of the day, the electron.
I
The
don't care
Let me
about the
talk.
fucking
Let me
algorithm. I
talk.
care about the real
Let
algorithm
me
in
talk.
reality.
Let me talk. Let me
That's
talk.
what I want to see.
Let me talk. I'm about to say exactly that. That's exactly what I was about to
Mhm.
say. Let me just say it.
Okay.
At the end of the day, let's say it's two electrons spinning. And the electron
Mhm.
spinning, it doesn't know math, it doesn't know cosine, it doesn't know how to square, it doesn't even know what a magnet is. A magnet is itself an analogy. It doesn't know. It at the end of the day, an electron just feels photons. An electron interacts
Yeah.
with the electromagnetic field with photons,
Mhm.
and the
Yeah.
photons they bounce against it, and the virtual photons, that's all it knows. At the end of the day, it's quantum mechanics. It's just photons
But
bouncing.
when the photon changes its spin, it's going to change the spin of the Planck units in the vacuum.
Okay, stop, stop,
So,
stop, stop,
because that's conservation of
stop,
angular momentum, you
stop.
can't
it,
you can't get away with that.
it's irrelevant.
Period.
Irrelevant. Everything you're saying is irrelevant.
No, it's not.
Yes, it
No, it's
is.
not.
No, it's for this discussion. It's irrelevant. Stop. Okay, let's continue reading the code. So, okay, let's see. Simulate.
What I
Um, let me.
the photon travel, its energy travels in a specific direction, but it's making state changes of the angular momentum quanta in the vacuum
Oh, I don't know.
that radiate away
Okay,
from it.
I don't
So
understand. I don't understand.
as it
Honestly,
travels in front of it, there's not going to be really,
I
anything, because it
don't.
hasn't reached there yet. It
I
hasn't
don't.
changed the spin states of the vacuum in
Stop.
front of it.
Stop.
It's changed the spin states
Stop.
from behind it, and
It
it's
it
reorganizing
doesn't.
due
Okay.
to conservation of
It
angular momentum
doesn't
and
matter.
balancing.
It doesn't matter. Everything you're saying not relevant for this entire discussion. Not
Oh,
relevant.
it's totally relevant.
Oh my god.
It's totally
Okay,
relevant.
stop, stop. Okay, well, my peak.
How are we going to get a physically grounded explanation if we don't like consider inverse energy relationships,
I don't know what you're talking
inverse
about.
state
I
relationships?
don't know what you're talking about. Let's continue. I want to read the code. You want to read the code? Let's read the code. Okay.
Because the only reason why you get a sine wave in a
Uh,
waveform
Nick,
is because of
Nick,
the energy
Nick.
distribution, the inverse
Oh,
energy
Nick,
distribution. It's not the sine
stop.
wave that creates, it's the
Shh,
inverse kinetic energy
shh.
distribution
Nick,
pushing on
Nick.
the other side of
Okay,
the
Nick.
energy.
Okay, shh. I don't understand you, so it doesn't. There's no point in
Like
talking
when we're
about.
talking about okay, so when we're talking about a sine wave, right?
I
It's
don't
an
know.
abstraction.
I
It,
don't
it's
know.
not it's not
I
it's not
don't
it's not it's
care.
not a contextualization of forces.
Stop. I don't
It's not a
care.
contextualization
I
of inverse
don't. I
energy
don't know what you're saying. I honestly.
directionalities.
Okay.
Well,
Stop.
when you have a
Stop.
particle, when you have a
I
wave,
don't
when you have a
care. I
wave in
don't.
the atmosphere,
Stop.
when you
I
have a
don't
sound
care.
wave, right?
Nick.
It bunches up and it
Nick. I
mimics the
don't
density of
care.
that mimics a sine wave,
Nick.
right?
I don't
So
care. I
that's
don't.
not a
Why do
sine
you?
wave is
I
not a
don't
physical
care.
explanation.
I
A
don't.
cosine is
Oh
not a
my
physical
god.
explanation.
Nick.
It doesn't tell you what's going on.
Shh.
I need the experiment.
Shh. Go find the experiment. What do you want from me? Go find the
Okay.
experiment. I'm not stopping you. Go find it. I want to
Yeah,
be.
but they're doing these
Go
photon they're shooting
find
these
it.
photons and they're
Go
traveling
find.
parallel to each other
Shh.
basically.
Stop.
Like they're literally going in the same direction.
Nick. I want to read the code. Please stop. I want to read the code. Let me read the
Mhm.
code. Okay. So we're in the function called simulate experiment. All right.
And it's going through a polarization lens, which
Stop.
you don't know how many times this thing
Stop.
rotated in that
Stop.
polarization lens
Stop.
and then
Stop.
communicated
Nick.
information and then
Nick.
went to the detector.
Nick.
Like
I'm
there's
gonna
so many
Nick.
errors with this.
Nick. Stop. I want to read. Do you want to read the code together?
That code doesn't mean shit, dude.
Okay. Okay. Let me read the code.
That does not derive truth.
Okay, I gotta read the code because I'm like I'm behind. I'm many hours of sleep behind my schedule, so I'm like
Okay.
collapsing. So I
Mhm.
can't argue with you. So just let me read the code. You're welcome to join me. So simulate experiment trials is 10,000. That's what I told it. Arrays to store measurement results for each angle. So angles. So it calls a range from 0 to 360. So in increments of of 1 degree. So 1 degree, 2 degree, 3 degree, 4 degree. Okay. Up count zeros, len angle. So the up count, it's setting up an array of up count and down count. It's just these are the ups and these are the downs. I don't know what it's going to use them for. Okay. For trial in range of trials. What is trials? Trials is 10,000. So it's going to go through a loop of 10,000. Okay.
I
Generate.
got a question.
Yeah, man.
Wait, I got a question.
Yeah.
Okay, so when the photon passes through a polarizing lens,
And yeah.
can we can we determine that it didn't stay at that polarization lens for a split, nanosecond or something,
I
then
didn't look.
shoot off?
I didn't look at that for a long time already. I forgot already anything that has to do with polarization. I'm sorry. I've been busy with entanglement.
Yeah, that is about this. Okay,
No, I
so if
know,
you
I
have
know. But not that experiment. You see what I'm doing? I'm doing like just I look at the plots. I don't care. I just look at the plots. I haven't looked at entanglement actual setups in a few weeks already, so I forgot everything. Let me read the code. I gotta understand this code. I need to make sure that there's no spooky action in the distance in the code. So So now we're doing the trial. So angle A is random uniform 0 360. Generate a random angle for particle A and the opposite angle for particle B. Okay, so angle A is going to be some angle from 0 to 360. Angle B is going to be angle A plus 180 mod 360. Good. Create particle pairs with entangled properties. So you're creating particle A with angle A, particle B with angle B. Next, measure particle A at 0. So particle A measure at 0. Is it up? Is it up? Then who? Lori. Hey, what's up?
Hey,
How are you?
good.
Hey. So we're doing Okay. So is it up? Good. Measure particle B at varying angles if particle A measured up. Okay. So for I, from angle in enumerate angles. So angles is a range from 0 to 360 by 1 degrees. Okay. If is A up, then result B, particle B, measure angle, where angle is, right, 1 degree, 2 degree, 3 degree. Good. If result B is up, then up count plus 1. Else down count plus 1, right? But this is just for this angle. So we're counting how many times, and we're running this experiment again and again and again and again. 10,000 trials. No, we're not doing this for 10,000 trials, or are we? No, for 360. We're doing it once for 1 degree, and then 2 and 3, and then 360, and we're done. And then we're repeating it a second time over 360 degrees, and a third time, and a fourth, up to 10,000 times. Uh, um, 1 second. But what about the up count and wait? What about the up count and the down count? So it says
It's not a valid experiment.
it's not. Calculate
No,
probabilities. Let me see. Let's calculate the probabilities. The up count over the up and the down.
because you can't determine. Listen here. You can't determine if you have two detectors right next to each other, and then
Hmm.
you're sending the photon through the polarizers.
Hmm.
You can't determine how long the polarization effect
Hmm.
or if it scattered photons from this end over to there or scattered because the detectors in the same general direction.
Hmm.
You can't make a determination because the measurement apparatus is leaky. I just don't know why they can't put the detectors in the opposite directions of each other and shoot the photons that way.
So
And there's a lot of experiments where they do that where you could see, okay, given the speed of light and given latency and how this interacts with this polarizer or this polarizer, there could be a convergence of photons from opposite ends ending on the same detector. So it's not good enough. It's not valid experiments, these photon experiments. So like if they can't like build a real world experimental device, then I can't fucking trust it.
please stop. I'm tired.
It's
Like
too leaky.
Nick, I'm about to collapse. I haven't slept in a long time. I'm trying
Mhm.
to. Okay, so what was that? Oh, he shut his mic
Hey,
off.
I'll be right back.
All right, man.
I'll be right back.
Yeah,
2 seconds.
yeah. Okay, so what he says. All right. Anyway, so up count and down count are arrays for the entire experiment. Experimenti. Are they? No, just for the 360. What is the size of up count? It's just angles.
If they build it like if there's a I can find a valid experiment.
So I don't get it. It's just 360? It doesn't look like 360. There's no way this is 360. There's many more, many points. Let me try to understand this. So it says plot angles, probabilities up. That's just a number. Where are we plotting the data? Where's the data? Where's the plot of the data? Where are we plotting the data? I don't get it. Angles.
Damn, I need a valid like experiment.
Validici.
I can't find a
Legend,
valid
title,
experiment.
Y level.
This is what I mean. Like, you can't trust these people when they don't deliver valid experiments.
Okay, okay.
They have leaky experiments.
Stop. Trying to understand the up count is only the size of the angles, which is just 360. Label, color, angles. So the plot is of angles. Angles is just the 360 degrees. The probabilities up is just the Y. The label and the color. Oh, PLT. No, can't be. Where are we handing over the up count, the actual data to be plotted? Where are we plot? I don't get it. What's going on? How does this work? And then you call simulate experiment. What is? Then you call it. So then you simulate the experiment. Then you simulate the experiment. Whoa, I'm losing power. Jesus Christ. One day I'm gonna lose this computer. I don't get it. Okay, I need to ask Gemini, where is the printing happening? Angles is the X, probabilities up is the Y, label is the label, color, X label measurement, Y label probability, title the label, legend, grid, show, simulate. Where are we telling it to plot, up count, or anything like that?
Man, I wish there was like a real
So
like
it looks like
measurement set up.
this plot has nothing to do with the code. Could it be the plot is fake? That can't be. It can't fake the plot. This is not ChatGPT. It can't fake, it can't hallucinate the plot. This is the plot. But where is the data? Where is the data handed over to the plot? Okay, let's ask Gemini. How are the points plotted?
Oh, you're iterating through this array, and you're storing ups and you're storing downs. Um, and you're
Oh, it says
graphing
that.
it out.
Oh, it says angles is the actual. How is angles the actual? It says here angles the x value. Oh, that's the x values. This is the y. Angles is
So
the
you're
x.
plotting angles, probability up, label, and then this is the label for the graph.
The angles is the x values. Oh, the probability up is the y. Okay, because it's not plotting every point. There's too many points. It can't plot all the points. Okay, it's fine. So it does an average. The total up for each iteration. It ran through the 360. Let's see. It went
Through an
th-
interval of one.
so it went through it
Oops.
went through
Yeah, went through.
so this is the most this loop is the most critical. Okay, so how is it plotting? So it's saying so angle in the beginning angles is 0.
Mhm.
No, but
And
it's
the end is
I. It
360,
goes through
and the interval
I.
is one. Yeah, I is a measure of
I okay,
the
okay.
interval,
I
I
get it.
think.
I get it. So it runs through the test. Got it. Okay, I understand. It runs through the test three right. It runs through the test of the 360 degrees. So up count one, up count one plus, up count one plus. It always adds one to up and one to down, whichever it went. However B said, is it up or down? So it's
Mhm.
writing down um, over the 360, and
Okay.
then it repeats this again 10,000 times. So up count I, so up count at 0, it's going to say a very big number. How many times over this test? At 0 degrees, did it go, was it up or down?
So
So it's
so
fine.
the
Everything is fine. It's
the
good.
vert
The code is good. Yeah.
yeah, the vertical. Okay, so probability of up of particle A, right? Or of the magnet.
No, this is B. Everything here is what we're saying up count is B.
Okay.
How many times did B point up for 0 degrees over 10,000 iterations? So it's fine.
So it's the ratio of up to down given a interval, right? A set of intervals.
It's not the ratio of up to down, it's up over up plus down. It might as well be up over down. It doesn't matter because it's just a plot. The point is the shape of the curve. That's the whole point. The shape of the curve, it's exactly as they got through their quantum entanglement. And I got it without quantum entanglement. Therefore, we don't need quantum entanglement. Roll the credits. There's no one on the Globe server. um, anyway, I think we're done. I think quantum entanglement is nonsense after all. It's a good proof. I think we're done. I think we can put entanglement behind us. It's fine. Everything is fine. X.com.
Hey, why is it? Sorry, I kind of missed the presentation.
Yeah.
Why is it quantum entanglement done?
What? What's the question?
Why is quantum entanglement done?
Because I'm able to reproduce the presentation of Fermilab using entanglement, and I'm able to reproduce it without entanglement.
How did you reproduce it without entanglement?
The code is in the collab, but it's just there's no
Yeah, take a
entanglement.
look at that.
There's just no entanglement. I mean, it's just a straightforward code.
He says there's no entanglement, but he's taken the angle differential from the other to calculate the other.
That's allowed.
Okay.
So
I'm
I
allowed.
just don't understand how
Um,
that's not entanglement.
that's not.
Also, I would actually, I would actually love to ask, because quantum entanglement is something that's observed when you do a measurement. This is just a piece of code, so
Yeah.
that's not a measurement.
Exactly.
I can easily write code that produces that graph.
But I
But
Exactly.
if
wrote
it has nothing to do with
no.
actual physical measurement, then I have done nothing.
No. So this code
Exactly.
no, this code simulates a physical device. It doesn't have to be quantum scale. I can reproduce this in any scale. I can reproduce this, right? I can build it. All I need to do is build a physical device that follows this code. As long as the device
Yes,
follows this code, I will get this graph without communication between the two particles.
I
So,
do agree.
so,
Have you built the device?
excuse me?
Have you built the device? I do agree that if you build a device that follows this code, then we might have a problem in our hands.
What do you mean we
So
might?
then the question remains, have you built the device?
I mean, look at the code. I mean, the device is this device, whatever it does, it's not going to need to communicate, right? I'm going to build a device
Yeah,
it's going to be called particle A, and a device that's going to be called particle B. These two devices are identical,
cool.
And I'm going to put one device on one side of the universe and the other device on the other side of the universe. Right, I'm going to first create them and I'm going to create them so that one is going to get a random spin in a certain angle, and I'm going to hide that variable inside particle A, and I'm never going to know what that variable is. It's going to be a hidden variable. And I'm going to take that variable and I'm going to take the opposite of that variable and hide it inside particle B. That's it,
Yeah.
2 hidden variables. Now I'm going to take particle A to the left side of the known universe, and I'm going to take particle B and move it to the right side of the known universe. And now I'm going to conduct an experiment on particle A. I'm going to pass particle A through. I'm going to ask particle A, please measure yourself at 0 degrees, meaning the magnet and your spin are no, the magnet is at 12 o'clock. Whatever your spin is, your hidden variable, whatever it is, just let us know. Did you flip a coin and decide that you're pointing that the result is up? Meaning we ran you through a magnet field. Did you go up or did you go down? And it doesn't really matter what the calculation is. Whatever it did, it decided to either go up or down. And let's say it went up. Now, if it went up, then we run the experiment on particle B. This is exactly what Fermilab, Professor Don Lincoln presented in his video. I'm following exactly his protocol by the letter. Now I'm running the experiment on particle B. I'm asking particle B, please please measure, and I'm telling you that the magnet is at 12 o'clock. And particle B, it knows its own spin, and it flips a coin, and it decides based on its own calculation if it goes up or down. And whatever it
But it's
does,
making its calculation.
hold
But
on,
it's
hold
making
on,
its
hold on,
calculation
hold on,
based
hold on,
off the
hold on, hold
angle
on,
differential.
please, please, hold on. And it doesn't matter what it does. It does some calculation internally without any knowledge of what A did, what it doesn't know anything about that other side of the universe. It doesn't matter what it did as long as there's no entanglement. I'm not allowing spooky action at a distance, no matter. And anyway, the point is, I'm able to reproduce the graph that they claim can only be reproduced because of entanglement, because of communing. Particle A is communing with B, and that's the only way they say they could get the red line. And I'm showing I can get
Yeah.
the red line with no communing. That's it.
See,
Yeah.
but when you ask the
Nick,
particle to do its
Nick, hold on.
calculation,
Nick,
you're
Nick,
taking in
wait,
itself and angle
Nick,
of the
hold on.
magnet.
Nick,
How does it know about the angle of the
Nick,
magnet?
Nick, let Lori ask, please.
Yeah. Yeah. Thank you. See, I'm just trying to understand, and I don't mean to bother you. You said that you followed the protocol. Yes, you don't. You said that you followed the protocol of Mr. Don Lemon. Now, I don't think that's true, because Mr. Don Lemon did an actual measurement, whereas you just wrote a piece of code. You didn't do an actual measurement. We can talk about it like this. My wife actually writes horror stories, you know. So if she writes a horror story whereby one particle, let's call that particle Mr. A, is taken to the right side of the universe, and then another particle, let's say Mr. B, taken to the left side of the universe. And then pink unicorns enable somehow through horror magic this graph to be produced in the story that my wife is writing. Have I done anything in reality to debunk this experiment? No, because I didn't do an actual measurement. Or my wife didn't do an actual measurement. My wife made up a story about what should happen.
No. The red line is not the data. The data is the black dots.
I know.
So
So I'm asking.
I'm able.
Yeah.
The question is.
Yeah.
The claim is that the blue line is the prediction according to hidden variables, and I show
Yes.
that it's the red line that is predicted from hidden variables. The whole discussion is hidden. You can see in Don Lincoln's presentation on the right side, and it's right now. Anyway, it's in the side chat, or you can see it on my stream. I don't know how to show it to you. I'll send it to you privately so you have it as well. 1 second. You are Lori. The whole discussion is, you can magnify it, open it so you see. So the blue line is the hidden variables according to Don Lincoln. And all I wanted to say is Dr. Don Lincoln is wrong. Because I can, right? This is mathematics. The red line and the blue line are predictions. The black dots is the experiment. So Don Lincoln said you cannot predict the experiment assuming hidden variables. And I used hidden variables and I predicted the red line. So Dr. Don Lincoln is definitely wrong. And quantum entanglement definitely does not exist. It's wrong.
Well, that doesn't mean.
Wait, Nick,
I don't know about
Nick, please. I'll speak to you as much as you want before and after. I want to talk to Lori for a few minutes, please.
Yeah, that's interesting, and I don't mean to bother you.
You're not bothering me.
Love to. Yeah, thank you. I don't wish to do that. So what I want to see, what I would like to see is how can you show that the code here has something to do with the physics of hidden variables?
Well, you can look at the code. The code, at the end of the day, the most important piece of the code is you can see my screen, my stream is the function measure. Right? The particle has a function, a short function measure with 3 lines of code. And measure doesn't use any information. There's no information from particle A or from that part of the universe of particle A. It doesn't use any information except for its own hidden variable and some calculation.
And an angle from the other particle.
Some difference of the angle cosine squared. It doesn't matter. It does some internal
because it's measuring itself relative to the angle of the other particle.
Nick, I'll talk to you as much as you want after. Lori, if Lori is talking to
me,
but
you're not being honest about this. You're lying about this because you're taking in the angle differential to calculate if it's up or down.
He can see the code. I'm not lying. The code is visible. It's public.
You are lying though.
But
you're lying. You're saying that the particle doesn't factor in the properties of the other.
Nick, the code.
In fact, that's not what you're doing here.
Nick, the code. Everybody can see the code. I'm not lying. I'm showing the code. Anyone can.
No, I'm showing you where you're lying inside of the code.
Okay.
I'm looking at the code.
Fine.
And
okay.
I'm showing
Nick,
you
Nick,
where,
I'll talk to you,
where
Nick,
you're lying.
Nick, we can talk after. Let me talk to Lori for a few minutes.
Look, angle difference equals absolute value of the hidden angle minus the angle of the other particle modulo 360.
Nick,
you are taking the information from the other particle to calculate the state of that particle.
Really? I'm taking the information from particle A? I'm taking information from particle A? Where do you see that? What are you talking about?
Self-hidden angle minus angle modulo 360.
Yeah. That's...
Yes, you're taking the angle differential.
Yeah, but nothing to do with particle A. I don't know anything about particle A. I mean, I can deduce.
But
No,
but wait, didn't you say the angle, the regular angle, not the self-hidden angle, but the angle?
the
Didn't
angle,
you say
that's
that was
that's the magnet. That's the apparatus on B. On B, we're testing with angle 1 degree, two
so
degree, 3 degree.
you're treating the magnet as the second particle, right?
No, the magnet is the apparatus in which we test particle B. The angle, the
Okay.
variable angle, is the angle of the magnetic field in which we're th- testing particle B. Particle B, we're throwing it into magnetic field with angle, with the variable angle, and then we're
Okay.
seeing, is it going up or down, and it goes up and down based on some internal probability, but this probability is calculated internally. The experiment on particle B doesn't need any information from the rest of the universe. I can easily reproduce the red line with no spooky action at a distance, just with the hidden variables, just as Einstein said. Everyone is wrong. Roll the credits. We're done.
So how would you show that the right way to do with these hidden variables, and I don't mean to bother you, how would you show that the right way to do this hidden variable measurement is to measure the angle of the device? Because I thought we were, and I correct me if I'm wrong, I thought we were talking about the spin angles of the particles.
Yeah.
So
That's what I thought.
why are
But
you talking about the angle of the device?
There's two
Yeah.
angles. Nick, hold on. Nick, hold on. So there's two angles. So particle A, the way we run this experiment, I'm following the protocol as per Dr. Don Lincoln. So we take a parent particle and we let it decay into two daughter particles. The parent is with zero spin. The daughter particles have opposite spins because of conservation
Yeah.
of angular momentum. We and then we take particle A and we test it just in an up or down magnetic field. We don't know what the angle of A is. Particle A is in some random direction. We don't care in what direction it is. We cannot
Mhm.
know exactly what it is. We just pass it in a magnetic field that is up and down. And we test particle A. Did it go up or down? If particle A goes up, then fine. Now we go to conduct a test on particle B. Now we go to particle B. And particle B, we don't know the angle in which it's spinning.
Mhm.
We know a little bit about it, but not too much. And now we're gonna pass it again through a magnetic field, but this time we're gonna pass it through, let's say, first we're gonna also pass it at 0 degrees, meaning up and down, and we'll get the result. Then we're gonna repeat the experiment, but this time measure for angle equals 1 degree. Then we're going to repeat the experiment, angle equals 2 degrees. We're changing the magnet, the apparatus. We're rotating the apparatus itself. We every time it's a different particle.
Mhm.
The spin is different. We don't know too much about it. We know a little about it, but not too much. And we're each time we're changing the angle 360 degrees. And then we're repeating the experiment 10,000 times. And the plot
Mhm.
that I'm getting is identical to the plot according to Bohr, to the Bohr model, whatever. Apparently, the whole argument is that if you assume hidden variables, you're supposed to get the straight lines, the blue lines, and if you're using the Bohr, which is the spooky action at distance, only then can you get the curves. And the difference is that's enough to claim that there's entanglement and the particle A is talking with walkie-talkie to particle B instant across the visible universe and nonsense like that.
Right.
And this is already, I mean, it's nonsense. It's obviously nonsense. We can put this chapter, very, very sad chapter of humanity, 100 years went down the drain with many, many very smart people wasted a lot of money, a lot of time, a lot of energy. Very sad, very sad.
I do agree, Mister, that you did follow the protocol as per Dr. Don Lemon. That's as far as the measurement goes. But I don't mean to bother you, Mister. I was asking, how is what you are doing with the code? How is it actually following from the predictions of the hidden variable model? And so I guess because you just talked about how do you do the measurement?
No, I don't
But
care.
that doesn't then answer that doesn't then answer my question, because my question was, how does your prediction from the code follow from the hidden variables model? We're not talking about the measurements. We're talking about the prediction. And you need to show that it follows from the hidden variables model.
I mean, you can see in the code the word hidden angle. That is the hidden variable. Particle B just needs to remember or to know its own hidden angle and the angle of the magnetic field of the apparatus.
Of what it interacts with.
Exactly. So particle
Got
B doesn't need any information from particle A. Particle B only needs the hidden variable. That's it. Just as Einstein predicted. Just as Einstein.
Yeah, because when particle A and B gets created, they get created from the same source, so they have opposite rotations due to conservation of angular momentum. So the angle of the measurement apparatus is not the other particle. You're saying it's, I see what you mean. That's valid.
Thank you. This is basically, this is, I'm using the hidden variables just as Einstein prophesized, and everything fits. It fits the data. So we're done. Einstein was right, Bohr was wrong. We can put this sad chapter behind us. Entanglement is nonsense. Just as Einstein said, Einstein and Schrodinger, Schrodinger used to make fun of these people. That's why he came up with the cat being alive and dead. I mean, he didn't know what else to do. I mean, Schrodinger was scratching his head. He didn't know what else to do. I mean, we know that Schrodinger and Einstein were having a big laugh. I mean, they were bewildered. They were talking to each other. They didn't know what's going on. I mean, obviously, the rest of the physics community lost their minds, and we lost 100 years of nonsense. This is trivial. This is
no.
But what if you get like some kind of pseudo entanglement where
hold on, Nick, wait
like
one
that,
second.
like where you
Nick, hold on. Yeah, Lori.
It's actually funny. I don't think the code that you provided simulates quantum entanglement and directly addresses the hidden variables.
What do you mean?
There might be another way to do it.
Nick, one second. Wait, Nick, one second. What do you mean? I mean, this code uses a hidden variable, the hidden angle, and that's all it needs. This is exactly as Einstein said it should work. This is exactly per Professor Einstein.
Did this code come from Mr. Professor Einstein?
No, this code is from Professor ChatGPT.
Okay, so it doesn't come from Professor Einstein. It comes from Professor ChatGPT.
Yes.
Just one more thing. I've been looking at the code, and it's quite interesting. It does a good job of showing how the entangled particles might behave But there's something that's been bothering me, you see.
Mm-hmm.
It uses the hidden angles to determine the measurement outcomes,
Mm-hmm.
which is a bit like the hidden variables.
Mm-hmm.
But here's the thing, in real world, hidden variables are supposed to explain quantum mechanics in a deterministic way, not just probabilistic like this code
It
does.
doesn't matter. It doesn't matter. There's no spooky action at a distance. Particle B does not need to commune with particle A. This is the entanglement is nonsense. This is what this comes to prove. Entanglement is nonsense. We can forget about it. It's gone. It's over. We're done. Roll the credits. It's history.
Just one more thing. Then
Mhm.
there's also Bell's inequality.
This
That's
is.
the real test to see if these hidden variables can match up with quantum mechanics.
I don't
So
care.
this
What
code,
is
well, it doesn't really test. You don't care.
No,
You should
because
care because
no,
you
no.
need
what
that
is
if you want to do
Nick,
what you
hold on.
want to do.
Nick, hold
what
on.
is Bell's
Nick, hold
inequality
on.
exactly?
Nick, hold on. Nick, hold on. So Don Lincoln presented this, and the title of his video was, and you can watch his video. He claimed that this is entanglement, and this is as weird as physics gets. And he basically said that this is a simplification of Bell's theorem. So this is his presentation. This is Fermilab, and this is the Department of Energy, and this is the European Space Agency, all behind. And this is Professor Don Lincoln that I appreciate a lot. Look,
Yeah, except for
one
their
second, Nick.
measurements are
Nick, one
leaky.
second. Nick, one second. So look,
Like we
Nick,
need to
hold
know.
on.
We need a valid
Nick,
experiment.
I don't want to mute you. Stop. So I didn't look at exactly Bell's theorem. I don't care about Bell's theorem. All I care for, all I care is the way Don Lincoln explained it. So as per Don Lincoln, he's wrong. If you want to talk now about exactly what Bell's inequality is exactly, we could do that too. But for now, Don Lincoln owes me and humanity an apology, and so
Hmm.
and so does everybody else.
I agree. He should not only apologize to you and humanity, but my wife as well, which is kind of a big deal. That is, if you can show that this code directly derives from hidden variables.
What do you mean? What do you mean? It says hidden angle. What else do you want it to say?
Yeah. I can write easily a story that says hidden angle. Like I can say hidden angle and unicorn farts produces this graph. But again, that's a story. And you
Look,
need to show that the story has something to do with the actual model. So
look.
how can you do that?
So the whole thing around entanglement is the claim that you can only reproduce the red line if you assume spooky action at a distance, that there's some information from particle A that particle B needs in order to reproduce the red line. And
Yeah.
in my code, I'm not using any information from particle A when I calculate particle B's red line. And that's all I need. That's it.
Hmm. That's not exactly the only thing you need. See, you need this code to actually have something to do with how hidden variables works in physics. See again, if this code has nothing to do with how hidden variables works in physics, in a real physical sense, then you just wrote a story. It's nothing more. It's a story written in Python, but that doesn't change the fact that it's a story that has nothing to do with hidden variables model, which you needed to connect to if you want to make your point.
Look, Don Lincoln said that hidden variables predict.
John Lemon.
No, Don Lincoln. Don Lincoln said that the blue lines is the prediction of hidden variables, and I show and
Yes.
he said the red line and the is the correct because the black dots is the truth. And I show that according to hidden variables, you also get the red line. Whatever.
Uh,
Hmm.
huh. I don't think that's correct, sir. See, here's the thing.
Hmm.
I think you showed that your code can produce the red line. But
Mhm.
you didn't show that hidden variables can produce the red line. Because again, you haven't shown that this code has anything to do with the physical theory of hidden variables, except that it uses the word hidden. There are many, many works of fiction that also use the word hidden, but we wouldn't say that those have anything to do with the hidden variables.
Okay,
So
look.
why is this piece of code fiction of
Okay,
yours
do you
any
know?
different?
Okay, do you know what entanglement means?
Yes.
Just to synchronize, do you want to tell me what your interpretation of entanglement is?
Yeah.
Go
You
ahead.
send a particle to the other side of the universe, you
Mm-hmm.
measure it,
Mm-hmm.
you measure the other particle,
Mm-hmm.
and the outcome of the other particle depends
Mm-hmm.
on the measurement of the first particle.
Fantastic. And in this code, do you see the measurement of B depending on the measurement of A in any way?
Mm.
Just yes or no?
No, so it's just yes, no, so it's a story that
Mm-hmm.
has a fiction that these particles have nothing to do with each other. It doesn't mean that it's in any way connected with the physical theory of hidden variables.
Okay. Look, I don't
It,
know.
we can simplify this. We can swap Python into just English, so it's easier to follow along. And I will tell you a story.
Mm-hmm.
Let's take particle A, let's take particle B, send them all to different sides of the universe, and then measure the two.
Mm-hmm.
And now there is some hidden variable, uh, and therefore this thing has been now demonstrably shown to be false.
But this is
I just used the word hidden.
yeah, yeah.
Oh,
I
I just
understand.
yeah.
I
I just
understand.
used the word hidden variable
I
in
understand.
my explanation.
I
But
understand.
does that mean that this explanation has anything to do with the actual physical model of hidden variables? No.
Look, so Einstein just told us he made a prediction that all you need
Yeah.
the Einstein just made a prediction that if you have a hidden variable, you should be able to reproduce the red line. And I showed that this is correct. I don't know what else. Okay, let me ask you how would you like me to prove Einstein correct? Meaning,
You
how
would
would
simply
hmm hmm
you would simply have to go into deeper understanding and find out what exactly in a physical sense
tell me, tell me,
does
tell
the
me,
hidden variable
tell
mean.
me, tell me what to do.
How do you yes,
Tell
I'm
me.
telling you what to do. So
Mhm.
why are you interrupting me so that you can ask me to tell you what to do when I'm already telling you what to do?
I mean the details.
It's
Don't
kind of yeah,
tell me the protocol. What or
yeah.
give me.
I'm giving you as many details as I can possibly give you. So how about you listen to what I have to say, and then afterwards, if you're not happy with that, you can ask more questions.
Okay.
So you need to look up how did we make these predictions? What kind of theory is there? What kind of theory background is there behind these predictions? And then you need to show that, okay, I can produce from this exact same theory background
Mhm.
that produced these predictions, I can use that to generate a code
Mhm.
that reproduces uh, this, this same line, the
Mhm.
curvy line instead.
Mhm. Mhm.
But this is not what you did, is it? Because
Yes,
what
it
you
is.
did is you just threw some words into ChatGPT. You have no idea what these graphs are actually based on. You just said, "Well, ChatGPT, can you give me some piece of code?" You didn't tell that it has to actually link back to the theory of hidden variables. You just said, "Can you produce this graph?" Well, of course, the ChatGPT can give you some bullshit that produces this graph, but if it doesn't link to the actual theoretical background that is called the hidden variables model, then your code has nothing to do with hidden variables model. It has something to do with hidden ChatGPT.
Okay. So what I did is I watched Professor Don Lincoln's video and I followed his protocol and his explanation of hidden variables. He said that hidden variables is basically, right, you create two boxes, and you have two balls, a red ball and a blue ball, and you put one ball in one box, the other ball in the other box. You mix the boxes, and then you send one of them to one side of the universe, the other to the other side of the universe. And then when you open one of the boxes, you see a blue ball, you know the other box is a red ball. That's the hidden variables. That's the way he explained it. And he said, based on this hidden variables, we expect the blue line, but instead we got the black dots. Therefore, the hidden variables is wrong.
Yes, agreed.
But I show that based on hidden variables, you don't get the blue line, you actually get the red line.
Ah, I don't think you showed that. You showed that according to your code,
Then tell me,
you get the red line.
okay,
But your code has nothing to do with the
what,
hidden variables model
then what,
because you just told ChatGPT to produce the line.
then what?
You didn't say
Okay, okay.
ChatGPT should base it on the hidden variables
It
model.
does. It doesn't. You can. Okay, forget about ChatGPT. So you can ask me questions about the code. So the question is, what exactly? What is the proof that you're looking for? Tell me what is the proof. I mean,
Hmm.
Dr. Don Lincoln says that the
Don
hidden.
Lemon?
No, Don Lincoln. He says that the hidden variables predicts the blue line, but I show that it doesn't. It predicts the red line.
No,
What?
no, no, no. You don't. You
No.
don't. You showed that your code produces the red line, not hidden variables. Your
But
code.
my code is based on the right. Look at the
No, no,
code.
it's not. It's based on ChatGPT. It's based on hidden ChatGPT, not based on
Okay,
hidden variables.
here's the code. Forget about ChatGPT. Here is the code. So
Yeah,
this code, right? The function measure is based only on, right? What is it? How is it doing the measurement? It only uses the hidden angle and the angle of the magnet. These, right? The hidden angle is the hidden variable, and the angle is the angle of the magnet. But there's no
yeah,
information from particle A or its apparatus.
yeah, yeah. Now you need to show that this is actually accurate to, for example, the hidden variable theory, like that proposed by Einstein.
But the
How can you show that?
hidden variable theory, I told you how Don Lincoln explained it. He said it's two
Yeah, yeah,
boxes. So I followed, right? The hidden variable principle is the hidden angle variable. That's all it is.
yeah, yeah. But you understand though, and I don't mean to bother you, that Mr. Don Lemon isn't actually the author of the hidden variable theory.
Then you
This comes from people like Einstein and people like this. So you need
okay,
to look at what Einstein has done
okay.
and what are the actual physics-based calculations that
Let's
Mr. Einstein's model, for example,
let's
has.
let's just talk
You didn't
about
do that, did you?
let's talk about just Don Lincoln's presentation. Then you agree that I've invalidated Don Lincoln's presentation.
Ah, no, not by no means, because Don Lincoln isn't saying that the simplified explanation that he gives in the video is actually the basis of the graph. He's getting the graph from Einstein's theory, which you need to look at. And you're agreeing with me currently that, oh, I didn't look at Einstein's theory, I just look at this video. So if you didn't look at Einstein, and people who are related to the hidden variable model, I think David Bohm is another one. So he has his own version of it. Um, if you didn't do that, then your code has nothing to do with the hidden variable theory, really. It tries to be that by using the same words, but like I can use the same words in any kind of fiction story.
Mm-hmm. Okay. I'm happy that, to me, entanglement is dead. So if you feel
Yeah,
entanglement, if you feel that entanglement is correct, then I cannot help you. You can continue believing whatever you want to believe. I'm done.
Yeah, you are indeed done, because I am happy with the fact that I showed you how your debunking of the hidden variables theory just doesn't work. It's a random piece of code that you got from ChatGPT that has no connection whatsoever with the theoretical background of hidden variables.
Hmm. Yeah, I already told you I'm happy with it. So if you have any further
Yes, yes,
questions,
you can be happy, but the hidden variables model is still alive and kicking. Typically in a Columba case, you're looking for the killer. This is a weird Columba case because in this case, the killer didn't kill anything. The killer is just pretending he killed something.
yeah, I'm happy. So
Yeah, yeah,
let's continue talking some other time because I think we're now just talking in circles.
yeah, yeah. I agree. I rest my conclusion with one simple quote: "Ignorance is bliss, Mr. Slave." So yes, you can be happy, but you're happy in ignorance.
Thank you. We'll talk later. Thank you so much for your time. I appreciate. Oh, he's not. Oh, you are listening. Yeah, I appreciate your time. Either way, I appreciate that you took your time and you're trying to, I can feel that you care for me and you want me to know the truth and know your truth. I appreciate that. I don't take it lightly. I appreciate your time. I appreciate your knowledge. I appreciate this discussion. It's also good content. Look, I might be wrong, but for now, I think to me it feels like a slam dunk. But I'm open minded. Maybe it's not. Maybe something is wrong with my proof that I haven't noticed. But for now, I think Einstein is vindicated. Schrodinger is vindicated. I think entanglement is done. There's no one on this server. Hmm. Let's see if these crazy people want to talk.
So if there's a force downward to the center of the Earth, then if you're rotating, it's still going to go to the center of the Earth. It's not going to change that in any way, shape, or form. What can change this direction is gravitational abnormalities on the Earth itself, like a lot of mass in one side of this plumb bob. So it will skew toward that greater mass, the density. That's the only way the plumb bob will move, not because of rotation.
Hey,
I think Jesse was trying to get in, maybe, or I don't know who
hey,
that was.
I just came to visit. Hi, everyone. I wrote.
Hold on, man. Somebody was trying to get in before you. Was that
Sorry.
Jesse?
Yo,
Hope it was Jesse.
I thought Jesse was trying to get in. All right, whatever. Go ahead, whoever.
Yeah, I have a short thing to say. So I wrote a program.
Is it on topic with this plumb? Hold on. Is it on topic with the plumb line thing that we're doing right now?
Oh, I'm sorry. You're in the middle of something. I'm sorry. No.
Yeah, we're live. We're live streaming
Oh, I'm
right now.
sorry. Sorry.
The only thing the plumb bob is going to be affected by rotation, it'll be lighter. It'll still have the same direction, but it won't be as heavy. It won't have the same force downward.
Wait. Where's the? Where do you give it a name? Oh, status for general. Entanglement and entanglement is finally dead. The death of entanglement. Hi, Seeker. Oh my god, no one understands anything. Let me try to sign into X. I think it's okay. All lives matter. White people bad. Racism in the woke era. Not racist. Stop white hate. Extremely racist. In fact, SpaceX received only half the money that Boeing did to develop a crewed spacecraft, yet has done all the completed missions. Unbelievable. Support the right to bear arms. There's no reason you need to own a gun. You literally just murdered my pet squirrel. What? Who says that? Elon, support the right to bear. What is he talking about? So we're winning. I am not Muslim. I am Persian. I hate Islam. Palestine in a nutshell. They're eating the dogs, they're eating the cats, they're killing the squirrels. Oh my god. Oh my god. Socialismo, capitalismo. So, capitalismo is terrible. Terrible capitalismo. Okay, how long have we been streaming? 3 hours. Alright. I think we're done. Let's take a break. We'll see you guys later. Yes.
Before we go,
Mhm.
you said that when we measure the angle difference,
Mhm.
that's not a difference between the angle of the spin of the first particle and the angle of that spin of the second particle, but it's the difference between the spin of the other particle and the device. But how is this then in any way related? Because shouldn't we be comparing the angles of the two particles with each other?
No, that's not at all what we're doing. Each particle is its own.
Isn't it?
What?
Yes, but here is the thing. How do you know? Because you're supposed to compare the spins of the particles to each other to know what the difference is between those spins. Because that's what the graph is showing. It's showing the difference in the spins. So if you now compare instead, if you're doing the difference based on the orientation of the equipment, then that means that you need to orientate the equipment to match the first particle for this to have any validity, which also means that you're actually validating quantum mechanics and spooky action at a distance.
So I'm not following what you're saying. So particle A is taken to one side of the universe, particle B to the other. They have no communication with each other. That's the
Yes.
test. And that's the code.
Yeah.
And this code, there's particles A and B don't share any information.
Yes.
Hmm?
So is the graph, what do you think it's supposed to produce? Is it supposed to produce the angle difference between the two particles or the angle difference between only the one particle and the measurement device?
I mean, it's there is a test that you perform. You have a
Yes.
particle that has spin, and you send it through a magnetic field that has an angle, and the spin of the particle has an angle, and these two angles interact in some probabilistic way. And based on
Yeah.
that probability, sometimes the particle goes up and sometimes it goes down.
Yeah.
Okay, so this is what I reproduce in my test. Now Bohr said, and Don Lincoln said that the red
Don Lemon.
line. Don Lincoln said that the red line can only be reproduced if you assume spooky action at a distance. If you assume that information from A leaks to B. But I show that I can reproduce the red line without leaking information from A to B. Don Lincoln said that the hidden variables gives you the blue
Don
line.
Lemon.
And I showed that. Why do you keep saying Don Lemon? His name is Don Lincoln. And Don Lincoln said that the hidden variables produces the blue line, but I show that the hidden variables produces the red line. So he's just wrong and wrong and wrong, and there is no entanglement. There's no need for spooky action at a distance. This is literally what Einstein said. So I think I don't see why we. What else am I supposed to say?
Yeah. Yeah. I don't think it is what Einstein said, because Einstein didn't produce this code. ChatGPT did. So this is what ChatGPT is saying.
If you have any further questions, I'm available.
Sure.
Thank you. All right, I think we'll cut the stream. Thank you everyone for watching. There's 3 people watching, but I think it's enough. 3 hours, and it was a good discussion with Dr. Lowry. Very nice discussion, and with Nick. I think we went through the code. I think we did well. It was a good stream. All right, everyone. See you later. Bye.